Here's number 6 from section 3.3. In this exercise, we want to find the derivative of y with respect to the appropriate variable. In this case, the independent variable is s, so we're after dy ds. So let's take a look at the function first. We have s root 1 minus s squared plus the inverse cosine of s. So I notice in the first term, we're going to need to use a product rule, and inside that product rule, we'll have a chain rule since we have a function underneath the radical. Then in the second term of the function, we have an inverse trig derivative, but it shouldn't be more than just writing out the rule since inside of this inverse cosine is just the single variable. So let's get started. For s root 1 minus s squared, we want to take the derivative with the product rule. And we know that product rule goes something like this. The first function, s, times the derivative of the second. The derivative of that second function by the chain rule will be 1/2 to the front times 1 minus s squared now to the negative 1/2 power, and then completing the chain rule times the derivative of 1 minus s squared, which is negative 2s. Then we move on to the second part of the product rule, plus the first function, which is root 1 minus s squared, times the derivative of the first. Derivative of s in this case is just 1. And then finally, we get to move to the derivative of the inverse cosine, and we know that's going to be the same as the derivative of the inverse sine, except opposite. So we begin with minus 1 over the square root of 1 minus, now whatever's inside that function squared, so s squared. Let's get to simplifying. In the first term, I notice that we have 1/2 times a 2, and that makes 1 when multiplied together. Then we have an s times a negative s, so that gives us a negative s squared in the numerator. And we're going to take the 1 minus s squared to the negative half and drop it to a denominator so that this first term simplifies to minus s squared, and then that's over a square root of 1 minus s squared. The second term, we're looking at root 1 minus s squared. So we have the square root of 1 minus s squared. And then finally, minus a root 1 minus minus a 1 over a root 1 minus s squared. So let's take a look at combining all three of these terms. I see root 1 minus s squared in the denominator of the first and the third term, but not the second. So right now that denominator is 1. We're going to multiply it by a root 1 minus s squared. And that means we have to do the same to the top to get our common denominator. So let's see where that brings us now. That's minus s squared from the first numerator plus a 1 minus s squared from the second numerator, since we took the square root times the square root of 1 minus s squared, minus a 1 from the third numerator, and that's all over that common denominator of the square root of 1 minus s squared. And I think we're ready for our final answer. I'm going to combine like terms in the numerator, and I notice negative s squared and another negative s squared. So that's negative 2s squared. And then we have a plus 1 minus 1. That makes 0. So this is the only numerator term we have. On the denominator, I'm looking at a 1 minus s squared still. And there's our final answer, negative 2s squared over the square root of 1 minus s squared.